Okay, good morning. We can start the session now. First, I will share you the screen now. One second. Can you able to view my screen? Okay, is that this one is visible for you? So this is the unit 3 properties of surfaces and solids. So in last session we have started and we have completed for our first CIA the centroid and the center of mass, then center of lines and areas, then centroid of rectangular, circular, triangular area, TI angle section and hollow section. Today we will start the area moment of inertia of plane areas like rectangle, circle, triangle area, T section, I section, angle and hollow section. It is moreover same as that of the centroid. Then we will discuss about what is meant by parallel axis theorem and perpendicular axis theorem. So in today's session, before that we can go through once what is the centroid we have discussed earlier. So if you take in the case of centroid, we will consider the plane or an area or a dimension of different profiles where is the centroid occurs. So if you take in the case of centroid, it represents the perfectly balanced surface, or like if you take center of gravity, it is the entire mass acts on a single point, but if you take in the case of centroid, it is used for a plane figure. So this we discussed in last session about how the center of gravity will vary for different positions. Then we have discussed for like different profiles or planes how the centroid is acting. Then we discussed about the center of gravity and the difference between center of gravity and centroid. Then this is the general one we used to use for our problem solving, like considering the first quadrant and mentioning what is meant by this OY and OX as the reference plane, then considering the x and y as the centroid axis, and we have discussed this about the symmetry profile also. So this is the some of the simple plane figures we have used earlier to determine the center of gravity. In general, we have used most of the cases with rectangular profile, that is L by 2, B by 2, and the area as L into B. So for last session, we have discussed about the square, rectangle, triangle, then right angle triangle, circle, semicircle, and semicircle with different axis profile, quadrant principles. So this is the general formula we use to determine the centroid of a composite plane figure, like x bar is equal to a1 x1 plus a2 x2 to the infinity, thereby the sum of the areas for x-axis and y-axis. So we have discussed these three major principles in our last session, that is symmetry about any one of the axes, either x-axis or y-axis. Then we have discussed about symmetry about both axes. This is your symmetry about both axes. Then followed by non-symmetry about any one of the axes. So this is the non-symmetry profile. Then we have discussed about this symmetry and determining the centroid, and we have solved many problems related to that. Also we have you I think you can get one problem in part C in CIA 1. So we have discussed all these problems in our last session during our offline class. So today we will start discussing about area moment of inertia of composite areas. So this screen is visible for you. Okay, please take a note. Area moment of inertia of composite area, that is a rectangle, triangle, circle, quadrant and semicircle, using standard formula method. So if you take in the case of this moment of inertia, what we have discussed earlier in the centroid, we will use to solve the half of the problem and determine where is the centroid. Then we will discuss about the moment of inertia. So if you take in the case of general classification between centroid and moment of inertia, centroid is defined as the moment of an area about an axis, centroid of a geometrical figure. So this is the centroid we discussed earlier in our session, that is for any profile we can able to determine where is the centroid, that is the central position where all your forces can rest in a single position. If you take in the case of this, moment of inertia is based on two major principles. One is called parallel axis theorem, another one is called perpendicular axis theorem. So this is, if you take in the case of this cylindrical profile, if you consider the center of the axis is called as a parallel axis theorem. Then if you take in the case of this one, we will consider an axis over here. So in this axis, how we determine our moment of inertia is using the parallel axis theorem. We will consider this as the height of the system, then followed by we will consider the area of the system, and moreover what we have discussed earlier in our centroid we used to do this. So this is based on the parallel axis, and this is the perpendicular axis theorem. So perpendicular axis theorem, parallel axis theorem helps to determine what is your moment of inertia about either x-axis or y-axis. If you take in the case of this one, that is the moment of inertia using perpendicular axis theorem, where helps to determine moment of inertia in the z direction, that is the polar coordinate condition. So please take a note of it. What is the difference between centroid and moment of inertia? Also, I want to mention that after this session I will share you the Google Classroom submission link for you. Whatever we have discussed today, please take a note of it and take a photo shot, and you want to submit in your Google Classroom that link, then only your attendance will be marked. Okay, please take a note of it, the difference between centroid and moment of inertia. So if you take in the case of centroid, it is the moment of an area. If you take in the case of moment of inertia, it is based on the parallel axis and perpendicular axis theorem. Okay, shall I move to next slide? Okay, please take a note of it, difference between centroid and moment of inertia. Centroid means moment of an area about an axis, centroid of geometrical figure. If you take in the case of moment of inertia, it is defined by two major theorem. One is called parallel axis theorem and perpendicular axis theorem. This parallel axis and perpendicular axis you may get as a 2 marks. But these two theorems are the basic principle to determine the moment of inertia for any of the sections or any of the surfaces provided in your question. Shall I move to next slide? Take down the general definition about moment of inertia. So in last session we have discussed about a general position of a centroid where helps to determine that. If you take in the case of moment of inertia, if you consider a long bar and it is applied by a force, the general formula for moment is force into distance, that is your force, and the distance is considered to be a moment. But if you take in the case of moment of inertia, it is the double the time of your force or double the time of your area. That is moment of inertia is equal to F into L into L, that is FL square, which represents the second moment of the force is called a moment of inertia, or the second moment of area is called as a moment of inertia. Please take down these two conditions. The second moment of force is called a moment of inertia, or else the second moment of area is called as a moment of inertia. For that, the general formula we used to tell is that moment of inertia is equal to F into L square. So this may be asked as a 2-mark question. Moment of inertia. Shall I move to next slide? Okay, okay. So like what we did in our centroid, we used to find some of the formulas for x-axis and y-axis like L by 2, B by 2, like for different shapes. Similarly, for moment of inertia also there are some of the standard formulas are available to define each of the shapes using your x-axis and y-axis condition. We will discuss that too today itself. I move to next slide. Shall I move to next slide? So take down moment of inertia, area moment of inertia. You just take down the shapes and what is IXS and IYY. The IXS represents, if you take in the case of a condition like a square rectangular profile, in this rectangular profile, if you consider the x-axis and y-axis, this is called the center of centroid. Wait, I just mark. So this is the centroid condition. For this centroid condition, we have determined already some of the formulas like L by 2 and B by 2 for the centroid. But if you take in the case of moment of inertia, the other formula is L B cube divided by 12 and BL cube divided by 12. That is LB cube divided by 2 represents the area moment of inertia for this rectangular profile with respect to x-axis. Similarly, if you take in the case of Iyy equal to BL cube divided by 12 for your y-axis. Okay, so please take down this formula. So with this formula, we can able to solve our problems easily. Take down for rectangular profile. The second one is the rectangular profile with a hollow condition. So in the middle of your rectangular profile, it is in hollow. That only you can able to find with white color, where it is a that is it does not have any material or it does not have any area in the middle. So that represents your rectangular profile with an hollow section, that is rectangular hollow section. For this, the general formula is LB cube minus of LB cube divided by 12. The capital L and capital B represents the external surface condition. The small l and small b represents the internal condition. Okay, take down this. So the first one is the for rectangular profile and the second one is for rectangular profile with an rectangular hollow surface. Take down. So this we discussed earlier in our centroid. In centroid, we have used the L by 3 and B by 3 as a formula to determine the centroid condition. Over here for moment of inertia, we use the next level of formula, that is LB cube by 12 and BL cube by 12. Shall I move to next slide? Okay, take down, take down. After viewing some of the surfaces, we will go to what is meant by parallel axis and perpendicular axis, and we will solve one problem on T section today. So if you consider in the case of T section, it is a combination of two rectangular surfaces. For the two rectangular surfaces, based on the x-axis and y-axis, first we will determine where is the centroid place, that is the x bar and y bar. After solving that, we will consider the parallel axis theorem that we will discuss in the next slide, and using that theorem, how the area moment of inertia can be determined for specific surface conditions. So whatever the formulas we are discussing today are some of the important one in general we use to determine the area moment of inertia. Shall I move to next slide? Take down the next three surfaces. The first surface is the triangle profile, the second one is a circular profile, and the third one is circular profile with a circular hollow section. So if you take in the case of your triangular profile, the height of the triangle is represented as h, the breadth of the triangle is represented as b, and the centroid we have already known in our previous centroid itself, so I have directly marked the centroid g over here. For the area moment of inertia with respect to x-axis and y-axis is bh cube, that is b into h cube divided by 36, and if you take in the case of y-axis, that is hb cube divided by 48. So these two are the important formulas used to determine the area moment of inertia. Okay, followed by the circular profile. The circular profile is fully solid type, where you can able to see only the diameters mentioned over here. For this condition, I-axis and Iyy, that is moment of inertia of x-axis and y-axis, you can able to find pi d4 divided by 64, because if you take in the case of x-axis as well as in the case of y-axis, for circular profile the formula is moreover same for both the axes. Similarly, for the circular profile with a hollow section, the inner diameter, that is your external diameter, is represented by capital D like our previous one. The internal hollow diameter is represented by small d. For this, the formula is pi d4 minus of small d4, that is capital D for higher diameter value minus of lower diameter value divided by 64. If you take in the case of both x-axis and y-axis, the formulas are same. That represents the x-axis and y-axis have a circular profile, will have the same level of dimensional parameters. So we have discussed earlier the rectangular profile with a rectangular hollow section. Then followed by we have discussed about what is meant by this triangle profile for area moment of inertia. Then a solid circle. Then followed by a circular profile with a circular hollow section. Okay. Take down. Shall I move to next slide? Okay, take down, take down. After this session, everyone must take a photo of your notes and you want to upload in your Google Classroom with the drive what I have shared. This will be available till today evening active. You want to submit within today evening 6 o'clock. Then only your attendance will be confirmed. After your online classes, when you come for CIA 2 or else for the end semester, you want to submit your notes for verification. Based on that only, your permission will be allowed for engineering mechanics. So please take note of it. But it is an analytical paper. The first 2.5 units we have did with the extreme condition. The another 2.5 units also we want to solve to the maximum. So please keep your notes moreover clear for your reference purposes. So please keep that in mind. Shall I move to next slide? Okay, okay, okay. Please take down. Yes. ஹாலோட டயாமீட்டர். கேபிட்டல் டிங்கிறது வெளியில இருக்க அவுட்டர் சர்ஃபேஸோட டயாமீட்டர். This is moreover same like your previous centroid. Only thing is that we will use this formula and we will apply this formula to the parallel axis theorem condition with reference to your first quadrant condition, and we will solve the problem. This is not a difficult one. If you are clear with your centroid profile analysis, you can able to solve the area moment of inertia for the similar type of profile itself, like an I section, T section, C section or L section, or with a surface with a hollow condition, you can able to do all these parameters. Shall I move to next slide? Now take down the other two profiles are, this is your semicircle condition and this is your quadrant condition. If you take in the case of semicircle condition, already we know the centroid formulas earlier. For Ix's and Iyy, that is area moment of inertia of a semicircle with respect to x-axis is 0.0068 d power 4. This is the formula to determine the area moment of inertia on the x-axis. Similarly, for y-axis for semicircle, the condition is pi d power 4 divided by 128. So these conditions are the standard formulas we used to solve for our area moment of inertia. Similarly, for the quadrant condition, the radius is provided for a quadrant. So the center of gravity we have already determined based on the previous one we did in our centroid. The formula for x-axis and y-axis is 0.55 r power 4. These two axes we can able to find the same formula, because when you take this one represents a 90 degree of revolution. Similarly, for 360 degree of revolution, we have determined previous over here for the circle as pi d for 4 divided by 64. For this condition, if you solve that, you will get first 90 degree condition. For that, the resolved formula based on the radius is 0.055 r power 4. If you take in the case of 180 degree of revolution, based on the diameter is 0.0068 d power 4, and based on y-axis is d pi d power 4 divided by 128. These two conditions are applicable only for the semicircle, and these two conditions are applicable only for the quadrant based on the 190 degree of revolution, either with respect to x-axis or with respect to y-axis. Take down, these two formulas are very important. Shall I move to next slide? Okay. Take down. So what we did earlier in our centroid, like we consider some of the formulas and we apply the formula to determine the centroid of a position of an some surfaces. Similarly, over here also, first the formula we will use the centroid to determine where is the centroid of a specific surface. Then we will consider the area, moment of inertia formulas to determine the in the moment of inertia based on x-axis and y-axis by the principle of parallel axis theorem and perpendicular axis theorem. Okay, parallel axis theorem means I will represent you like, if you consider a surface like this, and if I have my x-axis and y-axis like this, means this is my x-axis and sorry, this is my x-axis and this is my y-axis. So what is the height from the center of my condition? I will use over here like this. This is your height of the surface from our first quadrant x-axis. And how to solve this? Based on the principle we use here as a parallel axis theorem to determine the moment of inertia. Okay, shall I move to next slide? Now take down parallel axis theorem. So this figure only I have just drawn in the last slide. First you just see this figure alone. Please understand what it represents. If you take in the case of an AB, this AB represents the x-axis and x-axis represents the centroid plane. So this is the surface we are going to consider. The distance between your x-axis and the x-axis is the height. So if you consider the previous, or we can just see over here, I will show you. If we consider, so what this section representation is, it is purely a T section. In this T section, our centroid will be over, sorry, our centroid over here. Then our x-axis we will look over here. Okay, in this diagram, I am going to consider this as my section 1 and this as my section 2. This only we have discussed in our last centroid, and we will consider the area of the centroid for this section rectangular profile, then area of the section for the second rectangular profile, and we used to determine where is the centroid. If we solve this problem, we may get the centroid over here. Is that right? If we solve this diagram, we will get the centroid over here. For this problem, we are going to use the similar type of procedure, but what we are going to do over here is that based on this centroid condition, that is based on this centroid, how to determine the moment of inertia for our condition. For determining the moment of inertia for this condition, we will use the formula IAB is equal to IXX plus AH square. This A is nothing but, this A is nothing but what we have seen over here. That is, if you consider x-axis, means we will use this formula for area condition, that is BH cube divided by 36. Or if you consider y-axis, means we will consider HB cube divided by 48 for this area condition. So what is the height? If I consider the height from this section to this section as 60 centimeter or 60 units, this is your height. Then Ixx represents the moment of inertia for this condition. For this moment of inertia, we will use this condition also, that is LB cube by 12 or BL cube by 12. If you take in the case of rectangular profile, what is the area? L into B is your area condition. We will consider over here L as area as L into B. If you take in the case of Ixx, we will consider LB cube divided by, that is LB cube divided by 12. Then we will use the height as 60 square. So This represents the moment of inertia for IAB for this section. So can you able to understand what it represents? This is nothing but you can use for this also. So in the statement, it is represent that parallel axis theorem means it states that moment of inertia of a lamina about any of the axis. That is, if you consider a plane of lamina means it means the lamina represents, it may be a rectangle or it may be a square or it may be a circle or a quadrant or any profile, is equal to the sum of moment of inertia about a parallel axis. So can you able to understand, this is your quadrant x-axis, okay? So when you consider another one centroid over here, when you consider the centroid of a lamina which is in parallel axis. So generally when we consider like this means this is your parallel axis. When you consider like this means that is your perpendicular axis. So parallel axis, that is moreover like x-axis first quadrant, the parallel centroid axis is the plane of lamina, and the product of area, that is your area, and the square of your height. So this is the formula used to determine the parallel axis theorem condition. Please take down take down the statement of parallel axis theorem and perpendicular, that is your parallel axis theorem. So this formula what we have represented over here for IAB is equal to IXX plus IYY. This formula is an important one for our problem solving. If you consider in the case of your y-axis as a major principle, the like if you consider over here IAC, okay, I am going to consider IAC equal to I YY plus AH square. So can you able to understand what it represents over here now? If you consider the x-axis as a parallel condition, over here you want to draw another one line which represents that it is in y-axis. So this is your y-axis general one. This is your y-axis. Okay, so like this we want to modify the formula as per our requirement either in x-axis or y-axis. Also for your kind information, the parallel axis theorem can be considered only for the x and y-axis. The third axis like a perpendicular axis, that is your z, you cannot able to determine using this. Okay, please take down the formula and the definition about parallel axis theorem. It is an important 2 mark question. Please take down. If you take in the case of perpendicular axis, it is like izz equal to ixx plus iyy. That is your both axes what we consider. The perpendicular one is the sum of the both axes. That is your izz. So for your kind information, parallel axis theorem can be utilized only for determining the area moment of inertia for x-axis as well as for y-axis. It cannot be used to determine the z-axis. For z-axis third dimension, you can use only the perpendicular axis theorem. Okay, this formula is very important, that is ixx plus ah square. Shall I move to next slide? Okay, shall I move to next slide? Take down. So this is only we have discussed in last over there itself. Now take down perpendicular axis theorem. So the perpendicular axis theorem where you can able to find the z-axis. So in general, the general formula for our perpendicular axis theorem is IZZ. That is your moment of inertia for z-axis is the sum of your x-axis and y-axis. That is moment of inertia of x-axis and moment of inertia of y-axis. Or this IZZ is also termed as polar moment of inertia. In your question, if they have mentioned to determine the polar moment of inertia, means which represents, they are asking you to determine the z-axis based on the perpendicular axis theorem. So it is an one of the highlighting parameter over here. So the statement refers that if ixs and iyy, that is moment of inertia of x-axis and moment of inertia of y-axis, about two mutually perpendicular, please understand this is your perpendicular condition of area for x-axis and y-axis of the plane of lamina, and izz is the moment of inertia of the axis normal to the lamina and passing through the point of intersection of x-axis and y-axis. That is, it will pass over here. That is, if you consider over here as the center of gravity, means your z-axis also will pass over the O condition or centroid condition. So if you are using a perpendicular axis theorem, means which represents that it is the z-axis or z condition, or it is also termed as polar moment of inertia condition. Okay, please take down this. Please take down perpendicular axis theorem. Take down perpendicular axis theorem. It is an important homework. Similarly, parallel axis and perpendicular axis, these two theorems are very important and may be asked as a 2-mark question. Shall I move to next slide? So using these two theorems, that is parallel axis and perpendicular axis only, we are going to solve and determine the area moment of inertia for different cases. For this determination of area moment of inertia, first we want to determine what is the centroid condition of an surface. Either it may, we want to know either it is a rectangular profile or triangular profile or a circular profile with a hollow condition or a rectangular profile with a hollow condition. We want to know that, then only you can able to solve the parameter for this condition. Shall I move to next slide? Okay, okay. Shall I move to next slide? Okay. So in your question, if they ask to determine the polar moment of inertia, means you want to use this formula. If they ask only about determine the area moment of inertia, means you can use the formula like the parallel axis theorem and you can able to solve this clearly. Okay. Take down the first formula, that is first problem. Take down. So in this question, they will not provide you this figure. We want to draw this figure that represents, calculate the area moment of inertia of a T section of the flange. In general, in the T section, the second surface or the top surface is called as a flange. Similarly, the bottom surface or the supporting surface is called as an web. So they have provided only the information like T section, and they have provided the flange is 130 and the web is 2080. If they provided this condition, means you want to draw this diagram, they will not provide it. Like we want to consider the surface of flange like this and the surface of web like this. So we want to draw this and we want to mark the dimension. So the flange means 130. If you confuse the flange and web, then your problem will be like a different one. You will mark like this means it is like a perpendicular one. This is not a correct one to determine the T section. Like this, if you represent, this is your T section where your flange is 130, that is your x-axis. Like you can just solve, the first dimension is provided as x and the second dimension is provided as y. Like we used to do like this, x comma y. Like this you can able to use for flange and web. The flange is 130, web is 2080. So your height of your web is 80, the length of your web is 20. Similarly for the second condition we used to do. Please take down the given data. So for this flange and web condition, this is your T. First we will solve and determine what is the centroid. Now solve the centroid and tell the answer for this. Solve the centroid and please give your answer. So for x-axis, it is moreover clear. What is the value of x-axis? In general, it is an easy one, like we know the dimension of your flange as 100. Similarly, your web is connected to a flange. So you can able to find that your flange dimension is 100, which is divided by 2 means, which represents your centroid is in center of your condition. Okay, which represents your centroid is over here. Is that right? That means 100 divided by 2 is 50 mm, which represents the centroid of your x-axis will be in the center of your plane. That is, surely it will be pass in the center. That means if you take in the case of first section, the dimension is provided as 20. 20 divided by 2 means it is in the center, that is called 10, midpoint. Similarly over here 100 divided by 2 means it is 50, it is also in midpoint. Therefore your x-axis will be 50 because you can able to find the higher area over here. So this is the predominant one. So 100 divided by 2 is 50 mm. So the midpoint of your 100 is 50. So your x-axis of the centroid is 50. Now solve for y-axis and give your value. Solve for y-axis and please tell your value what it will be. Solve for first position and second position. Take your previous notes. You have the centroid formulas and how to solve it. We have solved nearly 2 to 3 problems with the same condition of T section. Refer that and solve how to solve and tell what is the value of y bar for this dimension or what is the y bar for this condition or the centroid based on the y axis. Solve பண்ணி சொல்லுங்க பார்க்கலாம். Anyone solved it? Any answers for centroid over y axis? கண்ணா சால்வ் பண்ணி ஆன்சர் சொல்லு பார்க்கலாம் சீக்கிரம். This is nothing but we used to use the formula like area is equal to L into B, then followed by y is equal to B by 2. Similarly for area for your y axis is area A2 is L into B and y2 is 80, that is your distance from your bottom condition is 80 plus b by 2 is your 30 divided by 2, you will get the 95. Then we will use the formula. This is your asymmetric general formula condition. Here we consider two sections, both the sections are rectangular profile. So a1 y1 plus a2 y2 divided by a1 plus a2. If you solve that, you will get 75.87. Please check and tell whether you get the same value. Okay, 75.869, where it is over here. So this is your centroid condition. So this is your centroid. 75.86 or 75.87. So this is your centroid. So can you able to understand now? So this is the first step we use to determine where the centroid is. That is, where is the center of gravity of this entire T section is. Then we will mark for our identification what is the middle of this condition and what is the middle of this section. So what is the middle of this condition? 30 means 30 divided by 2 is what? 15. So this is the middle condition. Similarly, for your second, that is your web, is 80 divided by 2 is what? It's 40. So we can do some reference points over here. These reference points are helpful for you during your problem solving. So why I have not marked in the x-axis like a similar one? I have marked for y-axis with the two conditions. That is, y-axis with respect to the second profile, middle point is this one. Y-axis with respect to the first position, I have marked one line. Why I have not marked for x-axis? Yeah, x-axis la mark பண்ணல. Any idea? Because it is perpendicular, also we know the centroid is what? Is 50 mm. It is in the middle. So if you solve this also, you will get the answer will be only in the middle of the condition. But if you take in the case of y-axis, two lines we have drawn because we have two different planes. One plane is having a dimension of 100, another plane is having a dimension of 20. When you solve this, you want to know at what distance these planes have the center middle point. For this only we have marked like this. So now first we will like this one we want to mark. I will tell you how to solve this problem. So after determining the moment of inertia of x-axis and y-axis, x-axis is what? 50 mm, y-axis is 75.87. so these two conditions we have achieved. Similarly, we want to solve for moment of inertia. First we are going to solve our moment of inertia based on the x-axis condition. Okay, so this is your x-axis and this is your y-axis. We are going to solve for x-axis condition. For solving for x-axis condition, we use the general formula. Where you have find this formula earlier? What this formula is called? IAB is equal to IXX plus AH square. This is purely a parallel axis one. So for parallel axis one, if you refer the previous that figure defined, we have taken this as AB. I will mark you this as A and this as B. Okay, then we have marked the condition over here. So for this one, the general formula is nothing but, if you refer IXX, it will be LB cube divided by 12. Now you go to your area moment of inertia general formula. For rectangular profile, the formula is LB cube divided by 12. Then followed by the general area of a rectangular profile is L into P. Then the height is, for this only we have marked the height over here. So what is your center of gravity, that is centroid for the x-axis? What is the centroid of x-axis? Is 50. Then followed by what is the centroid of y-axis? 75.87. So over here we are considering IXX over here for LB cube divided by 12. That is for x-axis. You consider the y-axis dimension. If you consider IYY, you will determine the x-axis condition as distance. So y1 is where you can able to find. Wait, I just show you. That is, your centroid condition is what for the previous one? That is x-axis. Your y-axis is what? Y-axis is 75.87. We have determined that. So For your formula, we are going to consider 75.87 or 56. We will consider this condition. And what will be the y bar now? So if you consider the profile from here to here, what is the dimension they have provided in the question? 80. Okay, so what is the center of this condition? Will be divided by 2. Is that right? Center means, if you want to determine the center of this condition, means is divided by 2, which is equal to 40. Okay, so this is only we are going to use over here. That is, height is 75.57, that is 75.87 minus of 40. Okay, so Ixx means LB cube divided by 12 plus area is L into B into your height difference. Now solve and tell what will be the value of moment of inertia for only first profile. That means we have solved only for one profile. I will show you. We have solved only for this profile alone. Okay, this is your first profile. So for this first profile, the height is 20 as well as your length is 20. Now solve and tell what is your moment of inertia for Ixx. You just calculate and take the dimension and just substitute over here and solve it. I have solved for the dimensions also. If you consider moment of inertia on x-axis, means you will consider the y-axis height. If you consider y-axis, means you will consider how much distance from your x-axis. Please tell what is the moment of inertia of x-axis for the first section. You just solve only the numerical values over here and solve it. The length is 20, breadth is 40. So 20 into 80 divided the whole cube divided by 12 plus your length into breadth is 20 into 80 into your height, already I have mentioned over here, that is 75.87 is the centroid condition, minus of midpoint of your rectangular profile is 40. So you can able to solve and determine this one. Just substitute the numerical values and tell what is your Ixx for the first plane alone. Anyone have determined what is your moment of inertia about x-axis? Yeah, any reason? Okay, divided by 12 plus 20 into 80 into 35.87 the whole square. The answer will be 2.91 into 10 to the power 6. The value will be very bigger. You just move your decimal points, you can get this value. Is that anyone solved this? 2.91 into 10 to the power 6 millimeter per 4. Correct? Correct? Oh, can you able to hear now? Okay. Yes. Can you able to hear me now? Okay. Shall we start solving for our second position now? That is your flange. You have determined for web. Now we will solve for flange. So this is your flange condition. For flange condition, what they have mentioned, for flange, what is the dimension? Your 100 and the dimension is 30 over here. Okay, start solving this one. I will show you the solution once for your reference. This is also using the same parallel axis theorem, that is Ixx plus AH the whole square. So Ixx is, if you take in the case of this one also, is purely a rectangular profile. If you refer the moment of inertia of a rectangular profile, you can able to find I b cube divided by 12, that is shown over here. That is for moment of inertia is L b cube divided by 12 plus area is length into breadth. Then your height is y2 minus of y bar. So y bar is what? Centroid condition we have solved over here. I just to show you. Your centroid is what? 75.87. But if you take in the case of your entire length is what? 80 plus 30 is how much? Once again, you just see here. You just consider this alone. What happens now? 30 divided by 2 is what? Over here it is 15 and on the above it is 15. Is that right? This is the midpoint condition. If you sum it, you will get the 30. So now we want to sum 80 plus 15. What happens now? 95. Okay. 95 minus of what is your centroid condition? 75.83. So this is the height condition we want to solve for this problem. So 95 minus of, see here, 95 minus of 75.87. Now solve and tell what is your moment of inertia about x-axis for your second profile over here. Solve it. This is nothing but you can use the same formula L b cube divided by 12 plus L into b y minus of, that is your y bar minus of y2, like that you can consider. Y bar is what? Centroid condition. Y1 and y2 is your, y1 is the midpoint for the section 1, y2 is the midpoint for your section 2. For section 2 we will solve from our the x-axis. The height of the condition is 80 and the midpoint condition is 15. Put together will be 95. Okay, for this value is 95. Here the value is 75.83 and here the y is what? 40. So if you are clear with these three values, you want to just substitute and determine what is the condition for this. Now tell what is your ixx2? What is your ixx2? Consider length and breadth and just solve over here. For this condition you will consider 95 minus of 75.83. That's all the major change. Other things are more over same, only the dimension is varied. 30, 100. What is the value of iyy? Sorry, ixx2. What is the value of ixx2? Can I solve பண்ணிட்டியா? எவ்வளோ வருது? Anyone have solved the ixx2? 11.3 into 10 to the power 6, like 1.32 into 10 to the power 6. 100 into 30 the whole square, sorry, whole cube divided by 12 into L into B. For length is 100, breadth is 30. 95 minus of 75.87 the whole square. You will get 1.32 into 10 to the power 6 mm4. So for this condition, moment of inertia about x-axis, you want to sum your what you have determined for section 1 and section 2 for moment of inertia. So ixx1 is what? 2.91. ixx2 is 1.32. So ixx, sum of your moment of inertia for x-axis is, that is 3 point, sorry, 3 2 4 point will be your answer. 4.23 into 10 to the power 6. So this is the moment of inertia for your x-axis. Can you anyone determine this value? ixx1 and ixx2, sum it, you will get the value as 4.23 into 10 to the power 6 millimeter per 4. Anyone solved this one till this process? Shall I move to next one? Okay. So next we want to solve for moment of inertia about y-axis. So initially we have solved and discussed for x-axis. Over here we are going to solve for our y-axis. For y-axis the central formula is the same one. Iyy equal to Iyy plus ah the whole square. That is, if you solve for X-axis you have solved LB cube by 12. Over here you are going to use BL cube by 12. That is the difference. Okay. If you just refer this, you can able to see for X-axis is what? LB cube by 12. For Y-axis is BL cube by 12. The area is same L into B. The distance on the X-axis you want to solve over here. Like, wait. Okay. So for this you want to solve for X-axis. For X-axis we have know already what is the dimension. What is the center of your X-axis? On the top you can able to find the dimension as 100. Okay. If you solve over here it is 50. Is that right? Your center point is 50. That is your centroid is also 50. Your center point for both the section is what? 50. Can you able to understand? கண்ணா இந்த ப்ராசஸ் புரியுதா? இது ஃபஸ்ட்டு செக்ஷன் எடுத்துக்கிறேன், இது செகண்ட் செக்ஷன் எடுத்துக்கிறேன். ஓகே, இந்த ஃபஸ்ட்டு செக்ஷனுக்கும் செகண்ட் செக்ஷனுக்கும் சென்ட்ராய்டு போடும்போது எவ்வளோ கிடச்சிச்சு? 50 கிடச்சிருக்கும். இந்த ஃபஸ்ட்டு செக்ஷனோட மிட் பாயிண்ட் எவ்வளோ? 100. 100ன்னு போடேன்னா அதோட பாயிண்ட் என்ன கிடச்சிருக்கும் உனக்கு? கண்டிப்பாக 50 தான். ஓகேவா? இந்த 20ன்னு போகும்போது இதோட மிட் பாயிண்ட் என்ன கிடச்சிருக்கும் உனக்கு? 10 தான் கிடச்சிருக்கும். ஓகேவா? அப்போ இந்த இடத்துல இருக்கிற டிஸ்டன்ஸ் எவ்வளோ வருது? 40 வரும். 40 + 10 போட்டேன்னா என்ன வரும்? 50. 50 - 50 என்ன ஆயிருக்கும்? 0 ஆயிருக்கும். ஓகேவா? அதுதான் இங்கே சால்வ் பண்ணியிருப்பாங்க. தட் இஸ் LB, L into B into x1 minus of x bar. x bar is centroid 50. x1 என்ன ஆயிருக்கும்? கண்டிப்பாக அதுவும் மிட் பாயிண்ட் சென்டரில் கிடைக்கும் போது இது ஆட்டோமேட்டிக்காக 0 ஆயிரும். 50 - 50 is 0. So the square is 0. Multiply with anything is 0. So you will neglect the entire term. You will solve only for BL cube divided by 12. புரியுதா? Can you able to understand this one? Okay. Solve and tell for IYY1 and IYY2 for first section and second section. First section is your web. How much? 53.3 into 10 to the power 3 mm4. Okay. Next solve for the second section over here. IYY2. For IYY2 also your AH square will be 0. You want to solve only for IYY2. IYY2 is LBQ divided by 12. You want to just use this both dimension and you want to solve it. That's all. Tell the value. What is your IYY2? IYY2 is 2500 into 10 to the power 3. This is 30 into 100 the whole cube divided by 12. அவ்வளோதான். AH square is A is area 300 into 100 and H is 50 minus of 50 which is 0. Automatically the entire term is 0. So 30 into 100 divided by 100 cube divided by 12. 30 is your flange length and 100 is the width. So you just solve and you will get 25, that is 2500 into 10 to the power 3 millimeter per 4. Can you able to find this one, get this value? அந்த டைமென்ஷன் மட்டும் எடுத்துக்கோக்கண்ணா. இங்கே இருக்குல்ல, they have given this dimension of இதை மட்டும் எடுத்தீங்கன்னா சால்வ் பண்ணினா வேலையை முடிச்சு. Breadth is how much? 30. The length is 100. The whole cube. Cube மட்டும் போட்டீங்கன்னா divided by 12. That's all. That is 2500 into 10 to the power 3. After solving this one, determine what is your IYY. IYY is equal to IY1 plus IY2. Solve பண்ணி பாருங்க பார்க்கலாம் எவ்வளோ வருதுன்னு. 255.3 into 10 to the power 3. That is your IYY value. This is the moment of inertia for your T section with respect to Y axis and previous with respect to X axis. That is, this is your Y axis with respect to X axis is how much? 4.23 and over here it is 3 point. So this is the answer for this problem. You can just take note of it. The first one 50,75.87 is the centroid. I moment of inertia with respect to x-axis is 4.23 into 10 to the power 4 we have determined. Similarly with respect to y-axis is 2.553. This is also we have determined. Okay. Is that everyone solved this problem? It is one of the important 16 mark problem direct question for your end semester examination. Please mark a note of it. Similarly, centroids may be asked only as an 8 mark question, but the moment of inertia, area moment of inertia will be asked as a 16 mark question. Okay. So today you can take this as a homework. Please take down this problem. Take down this. Calculate the moment of inertia of an angle section shown in figure about the centroid axis xx and yy. Take down this dimension. Over here also the dimension is 20. Take down. Consider this as section 1 and consider this as section 2. Solve this problem and you want to submit this problem by today. Okay. Also you want to solve what we have discussed today in the class session in your Google Classroom. Similarly, you want to solve this problem and you want to submit it in Google Classroom by today itself. Okay. I will share you this problem in Google Classroom by now. Okay. Also for your kind information, the attendance will be taken over here using the application attendance tracker. So it shows how many minutes you have present in the session and how many of you are present. So please inform everyone to solve and give your notes and everything in the Google Classroom. Okay. Thank you very much and have a nice day. Your session is over. இல்லை நான் சால்வ் பண்ணி இதில் உங்களுக்கு கூகுள் கிளாஸ் ரூம்லேயும் வாட்ஸ்அப்லேயும் சால்வ் உங்களுக்கு அனுப்புறது. ஓகே. ஓகே, தேங்க்யூ. தேங்க்யூ.